Ever wondered why we have earthquakes, volcanoes, and mountain ranges on our planet? It's not a random coincidence or the work of mythical creatures from ancient folklore. No, these natural phenomena have a scientific explanation rooted in the very structure of our Earth. They're connected to something that's happening right beneath us, something that's constantly shaping and reshaping our planet. So what's the secret? The answer lies deep beneath your feet, in the fascinating science of plate tectonics and Earth structure. Imagine peeling an onion, layer by layer. Just like an onion, our Earth also has multiple layers. Picture the Earth as a giant fruit with three main layers: the crust, the mantle, and the core. The crust is the thin outer layer, similar to the skin of an apple. It's the layer we live on, and it contains all the mountains, valleys, and oceans we see around us. Next, we delve deeper into the mantle, which is akin to the flesh of an apple. It's much thicker than the crust and makes up about 85% of Earth's volume. Finally, we reach the core, the heart of our planet. It's like the seed of the apple, and is divided into two parts: the outer core, a sea of molten iron, and the inner core, a solid iron sphere. So, we live on the crust, the outermost layer of Earth, which is not just one piece, but it's broken into large pieces called plates. These plates, they're not stationary, they move, and this movement is what we call plate tectonics. Imagine the Earth as a giant puzzle composed of large pieces called tectonic plates. These plates aren't just a flat surface, they're thick, heavy, and extend deep into the Earth, comprising both the crust and the upper part of the mantle. This combination of crust and mantle is known as the lithosphere. Now picture these plates floating on a semi-fluid layer beneath them, known as the asthenosphere. The heat from the Earth's core causes currents in the asthenosphere, similar to the way soup bubbles when it's boiling. These currents push and pull the tectonic plates, causing them to move. This movement, albeit slow, is continuous, with plates moving at about the same rate as your fingernails grow. The interaction between these plates can lead to significant geological events. When plates move apart or diverge, magma from the mantle rises to fill the gap, forming new crust. This process, known as seafloor spreading, takes place mostly under the oceans, and is responsible for the creation of mid-ocean ridges. On the other hand, when plates collide or converge, one plate is often forced beneath the other in a process called subduction. The subducted plate melts in the mantle, and the molten material can rise to the surface, resulting in volcanic activity. Lastly, plates can also slide past each other, a process known as transform motion. This movement causes immense stress buildup, which when released results in earthquakes. And it's not just about volcanoes and earthquakes. The movement and interaction of these plates over millions of years have shaped the Earth's landscape, leading to the creation of mountain ranges, valleys, and deep ocean trenches. So the next time you feel the ground shake beneath your feet, remember it's just the Earth's plates doing their dance. So, let's put all these pieces together. We've embarked on a journey to the very core of Earth, peeling back layer by layer to reveal its secrets. We started with the crust, that thin, solid outermost layer that forms the surface where we live. But beneath our feet it's a whole different world. The crust is divided into tectonic plates like pieces of a giant jigsaw puzzle, constantly in motion due to the heat and pressure from the layers below. Now let's dive deeper, past the crust and into the mantle. This hot, semi-solid layer is responsible for the movement of the tectonic plates. As the mantle's material heats up and cools down, it creates convection currents that push and pull the plates in different directions. Finally, we journeyed to the core, the heart of our planet. Composed of a liquid outer core and a solid inner core, its extreme heat and pressure play a significant role in Earth's magnetic field. These movements and interactions of the plates can result in some of Earth's most dramatic events: earthquakes, volcanic eruptions, and even the formation of mountains. It's a dynamic, continuously changing system that shapes the world we live in. And that, my friends, is the fascinating world of plate tectonics and Earth structure. Until next time, keep wondering and keep exploring.